This video is not going to be full solutions, but I wanted to kind of address some of the questions I anticipate people are going to have about this assignment and kind of give you some hints for this as you're working through the exam. So I'm going to go in order for the questions. First of all, we've got a collection of 3 golden rectangles here. So we've got this is a golden rectangle, this is a golden rectangle, and this is a golden rectangle, all of which have this setup where the long side is equal to the short side times phi, where phi is around 1.618. Thinking about this one here, so this has dimensions a times b, or a by b, and so we could say something like a is equal to phi times b. For this one, we can think about this as being the long side, and this as being the short side. So we could say something like b plus b, or 2b, is equal to c times phi, right? Long side is equal to the short side times phi. And then the last part here, we're looking to find b, but it says the area of all 3 rectangles is 200. So that's going to be this dimension times this dimension is equal to 200. So that first dimension, that vertical one, is going to be 2b. And then for area, we multiply. So 2b times c plus a is equal to 200. So if we let these 3 be our system of equations, then we can solve for a, b, and c because we've got 3 equations here. Number 2, we have that same long equals short times phi, but then we also have this we have this long equals short times phi. We also have the whole thing is equal to the long side times phi. So this whole thing, if we divide that by phi, we're going to get this piece here, and then we'll have the long piece and the short piece there. Okay. For number 3, we're looking for the perimeter of the golden triangle below. So that means we want this plus this length. This type of golden triangle that I've drawn here, so based on the shape, you've got 2 of them, right? Ones that look like this and ones that look like this. This one here has 1 short and 2 long sides. This type has 1 long, right? So here's the 1 long side. And that's got 2 short sides there. So once you figure out the long and short sides, just add those 3 up, and that'll give you the perimeter for that. For number 4, we're talking about sequences, and this is not a Fibonacci type, but it uses the same kind of language that we had in the Fibonacci types. So this says a sub n is equal to negative a sub n minus 2 plus a sub n minus 1 minus 3. And we can think of these terms. So for example, this term a sub n minus 2 and a sub n minus 1 as being, we've got terms, a, b, c, d, e. If we're talking about this term, a sub n minus 1 is going to be the one before it, and a sub n minus 2 is going to be the one before that. So it seems like in this equation, just like a Fibonacci, our next term is going to depend on these previous two terms. So you could set this up to say a sub 3 is going to be equal to negative, so 2 behind that is going to be a sub 1 plus a sub 2, right? This is 1 before a sub 3. And you can figure out a3, and then you can use that to figure out a4 as well. For number 5, you can figure out, so I'll tell you that this is a geometric sequence, and then I want you to look in your notes for a formula for a sub n for a geometric sequence. If you need help finding the common ratio r, you can always take any term and divide it by the previous term. So we could say that this is 99 divided by 8 divided by 33 over 4. Just make sure that your parentheses are all intact when you're doing this, but that should let you find the common ratio. Number 6, the interior angle. So this is going to be probably the toughest one on this practice exam. But it's just going to use what we know about arithmetic sequences. It says the interior angles of a polygon form an arithmetic sequence if the common difference is 27. So we'll go ahead and write down what we're looking at. And the measure of the smallest angle in the polygon is 54. How many sides does the polygon have? Now, common difference is 27, right? And so we want to think of our sequence as being, so I'm just going to draw some, right, some six-sided. All right, some six-sided shape, or five-sided in this case. But we've got the smallest angle, and then the second smallest, and the third smallest, and the fourth smallest. And then all of those together are going to add up to something. So if we think about a sequence of these angles here, like it describes in the beginning there, we can say our first angle is 54 degrees, and then our next angle is going to be, so it says a common difference is 27, so we've got 54 plus 27, and then we've got 54 plus 27 plus 27. And we're trying to figure out how many times we need to add that 27 in order to get something reasonable for a total. All right. So I'm going to simplify this a little bit. We've got 54 as our first angle. And then 54 plus 27, that's going to be 81. And then after that is going to be 108. And you get the idea. Okay. So I'll call this our first term, our second term, and our third term, and those are going to be the different angles, right? We've got 54, 81, 108. Right, and this is just going to keep continuing until we get our shape that we're looking for. One thing we know is that our sum of interior is going to be equal to n minus 2 times 180 divided by n. All right, that's our formula from exams 1 and 2. And another thing we know is that the sum of interior, that's these ones here. We also know that the sum of a sequence for an arithmetic S sub n is going to be equal to a sub 1 plus a sub n times n divided by 2. So if we give myself some more room here to work with this. So this is the sum of arithmetic. These two things should be equal to each other. So we're going to need to fill in a couple things about this one here, but I'm going to just write out that these two are equal to each other. Right. Some of these things we can fill in, right? So we're trying to solve for n here. A sub 1 is 54. A sub n, we don't know what that is, but we do have a formula for that based on our common difference. So start filling in things here. A sub n for an arithmetic sequence is going to be, put that in brackets here. It's going to be a sub 1 plus n minus 1 times d. That's going to be multiplied by n divided by 2. We know that D is 27 and the A1 is 54. So from here, we've got a formula that we can solve for n, right? N is the only variable here. Rather than try to wrap that GeoGebra solve around this, what I would suggest is getting this in a form that looks really simplified, right? Is trying to get this as simplified as possible. And then once you've got that, you can take that to GeoGebra and use the solve command on there. So remember, that's geogebra.org/calculator. Okay. Number 7. This is similar to what I went over in the other video, where you find the measures of centrality on GeoGebra. So I'll leave it up to you to watch that other video. If you have any questions still about finding the centroid, incenter, circumcenter, and orthocenter, those 4 are also going to be something that you're looking for here. So I'll just tell you how I would kind of narrow these down. So again, we've got the centroid, incenter, circumcenter, and the orthocenter. So I see that these 2 are outside of the triangle, so that tells me that we're probably looking at the circumcenter and the orthocenter for those 2. Same triangle every time, right? So we can just look at the different spots where it might show up. For this one that I'm looking at here, the third one, I can kind of see the incircle on here, right? That's the spot where I would put the largest, where I would put the largest circle inside there. But just to double check that, I can look at any of these vertices and see that I've got angle bisectors in any of those. So this one here, this is the other one that's on the inside. This is connecting, I've got at least one line here connecting a vertex to the midpoint of this line here. So I believe that one. For the circumcenter and orthocenter, we do have lines that make this up, but in order to distinguish these 2, I'm going to think about the circumcenter. The circumcenter, remember, has that circumcircle that touches all. It's a circle that would be centered here or here, that touches all 3 of the points on there. So when I think about trying to make that, here's a circle centered here, right? I think about the distance, right, of a circle centered at any of these 3. That doesn't really make sense to have a circle centered here that touches all 3 of the points like the circumcenter would. But if I look at this point here, I can believe that these are all 3 the same distance, right? I have a circle that touches each of these 3 points there. So I would call this one the circumcenter. This one you also have an example of, but this is a question where you have 3 similar triangles. So I would follow that method that we saw either in class or in the video recently, where this is the small triangle, this is our medium-sized triangle, and this is our whole triangle here. Just fill in everything that you can, right? And you might have to come up with a name for one of the missing sides on there that might help you out and solve for that. But yeah, between setting those up, right, label some angles, alpha. Here, I'll call the small one here alpha, beta, right? Let's see, for this medium one, this will be y. Down here for this one, hypotenuse is 10. Okay, these are all right triangles. Hypotenuse for this one is 5.5. Right. So maybe this missing piece here, here's another one, 5.5. Right. So maybe you can use these three pieces to find this missing piece here, right? And then maybe you've got this piece and this piece. So my suggestion for a second, kind of a secondary thing in the middle to find would be this x here. We're going to call that x. See if that doesn't, solving for x doesn't help you figure out this missing piece here. Okay. So this is pretty similar to what you saw in the assignment. So we've got all those side angle, side, and things like that. My suggestion for this one, I had a lot of people actually come up to me and ask about the homework. They said there must be some mistake, but if I tell you triangle ABC is supposedly going to be congruent to triangle EDF, my advice is to just draw two triangles, A, B, C, and E, D, F, right, with all of the spots in the same spots that they need to be. So B lines up with D, E lines up with A, right? So that's all set up. And then just label these things here, right? Once you label those three angles on both triangles, then you can kind of see what situation you're looking at, whether it's side, or side angle side, things like that. All right, hopefully that was enough of a hint to get you started. I'll post complete solutions by tonight, which is Thursday night. But yeah, good luck on the practice exam, and I'll be on Zoom